In this rapid review video, we're going to be looking at subtracting mixed numbers, but specifically subtracting mixed numbers when we need to regroup. So let's go. Here's our first problem. 9 1/5 minus 3 1/3. You can see that I still have those same steps that we've seen in my other rapid review videos for adding and subtracting fractions, because we're going to do the same thing. It's just going to look a little different because we're going to be subtracting mixed numbers and we are going to have to regroup. But the first thing we're going to do is estimate our answer. Remember, we're rounding those fractions to benchmark numbers to give us an estimation of what our answer should be. So let's look at our first fraction, 9 1/5. We're going to look at the fraction piece, 1/5. I know that 1/5 is very close to having no fifths at all. It's very close to 0. So I'm going to round 9 1/5 to just 9 wholes. 3 1/3 is what I'm going to round next. When I look at 1/3, I have 1 out of 3 pieces. That's very close to having no pieces at all, just my wholes. So I'm going to round 3 1/3 to just 3. 9 minus 3 equals 6 wholes. So I know that my answer should be around 6 wholes, reminding myself that I rounded down both times. The next thing that we're going to do is find a common denominator. Remember, we can find a common denominator using the least common denominator, the LCD, or the easiest common denominator, the ECD. Let's look at the LCD first. I'm going to take my denominators, 5 and 3, and I'm going to find that least common multiple. The multiple that's the same between 5 and 3. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. I'm going to stop there because I think I just found it, but let's make sure. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15, and there is my least common denominator. 15 and 15, multiple of both 5 and 3. Looking at my easiest common denominator, remember all I do is multiply my two denominators. 5 times 3 equals 15. So whether I use the least common denominator or the easiest common denominator, for this problem, that denominator is going to be 15. Moving on to step 3, we're going to make equivalent fractions. I'm going to rewrite my fractions vertically, just because it's going to help me out as I make these equivalent fractions. 9 1/5 minus 3 1/3. All right, so I'm going to make my equivalent fractions, reminding myself before I do to bring over my whole numbers. 9 and 3. I don't want to forget them or it will vastly change my answer. Now, my equivalent fractions are going to have 15 as its denominator, because 15 was both my least common denominator and my easiest common denominator. To get an equivalent fraction, I multiply the numerator and the denominator by the same thing. 3 times 5 equals 15. What I do to the bottom, I do to the top. 1 times 5 equals 5. 5/15 is my first equivalent fraction. Looking at 1/5, 5 times 3 equals 15. What I do to the bottom, I do to the top. 1 times 3 equals 3. 3/15 is my equivalent fraction. So now I have 9 3/15 minus 3 5/15. So I'm going to look at those fractions first to subtract. Remember, I only subtract the numerators. 3 minus 5. Well, wait a minute. I can't do 3 minus 5. Does that mean that I can't solve this problem? Nope. Go look at your whole numbers. We have 9 wholes available right here. We only have 3 wholes here. 9 3/15 is definitely the bigger number, which means that I can subtract. But just like if we were to have this problem, 12 minus, 0, 5. I can't do 2 minus 5, right? But I can definitely do 12 minus 5, but I have to regroup. I have to take something away from the tens place, and I have to add it to my ones place. We're going to be doing that same thing, but with fractions, instead of whole numbers. So come on over here and look at our problem. 9 and 3/15. I'm going to need to regroup one of my wholes. So I'm going to turn the 9 into 8 wholes. And I'm going to add this one whole to my fraction. But I'm not going to add it as one whole because we know that we have to have a common denominator when we add. So what's another way to write one whole? Maybe as a fraction? Well, if my denominator has to be 15, then my numerator has to also be 15. Because when the numerator and the denominator are the same, that equals one whole. So I took one whole away from 9 and made it 8. And I'm going to add it to my fraction, but I'm going to add it as a fraction. So I'm going to have to rewrite my problem one more time. This time I only have 8 wholes, but I have 15, 16, 17, 18 pieces. I turned my completely mixed number into now this kind of weird looking fraction with a part of a mixed number and part of an improper fraction. But don't worry, this is what I need in order to solve my problem. My bottom fraction remains the same, 3 and 5/15. Now I can subtract. Let's get rid of this part so I have a little bit more space to work with. All right, here we go. 18 minus 5. I can do that, whereas over here, 3 minus 5 I could not do. 18, 17, 16, 15, 14, 13. So I have 13 out of 15 pieces. And now I do my wholes. 8, 7, 6, 5. So I got the answer of 5 and 13/15. I'm going to go to step number 5 and simplify if necessary. 13 over 15 are both odd numbers, and there's no number that can go into both 13 and 15 other than 1, so it's already in its simplest form. So 9 and 1/5 minus 3 and 1/3 equals 5 wholes and 13 out of 15 pieces. The last thing I'm going to do is check with my estimated answer. I should have gotten something around 6 wholes, and in fact I did. 13 out of 15 pieces is pretty close to 1 whole, or 15 out of 15. So this is close to 6 wholes. So I know that my answer is correct. So that's how you solve a subtraction problem with mixed numbers when you have to regroup. But before I stop this video, I want you to take a look at this problem here. Very similar to the problem before. The only difference is that this problem doesn't have a fraction in the first number. I'm going to show you how to solve this kind of problem too. Just like before, we're going to start with estimating our answer. Since there aren't any fractions in 9, I can leave 9 alone. 3 and 1/3 is the same number we had in the previous problem. Don't forget that we rounded this to 3. So just like the first problem, this should also be close to 6 wholes. But again, it will be a different number because we don't have a fraction right here. All right, finding a common denominator. Now, you might be a little bit confused. Since we don't have a fraction over here, how can we find a common denominator? It's actually a lot easier when we do this because our denominator is simply going to be whatever the denominator is in our fraction. So let's rewrite our problem. 9 wholes minus 3 and 1/3. Now, I can't take nothing away from 1/3, right? So how many extra pieces do I have if I have 9 wholes? I don't have any extra pieces, so we can put a 0 there. Well, how many pieces make a whole? 3, because we want to have that common denominator. So we might as well make the denominator what we already have. So we could read this as 9 wholes, or you could read it as 9 wholes and 0/3. It's the same value. We're just writing it a little bit differently so that we can solve the problem. All right, now we can subtract. 0 minus 1. I can't do it, right? So I'm going to have to regroup. I'm going to have to take a whole from my 9 and turn that into an 8 and add my whole over here to my fraction. Well, if I'm talking about thirds, 3/3 equals 1 whole. So the problem I'm going to solve now is 8 wholes and 3/3. Isn't that the same thing as 9 wholes? Yep. Minus 3 wholes and 1/3. Let's look at my fractions first. 3 minus 1 is 2 out of 3. 8 minus 3, 8, 7, 6, 5. So my answer is 5 2/3. I'm going to simplify if necessary, but I already know that 2/3 is the simplest that fraction can go. So my answer, 9 minus 3 1/3, is 5 wholes and 2/3. The last thing I'm going to do is check with my estimated answer. It should be close to 6 wholes. 2/3 is pretty close to a whole. So 5 2/3 is pretty close to 5 plus 1, or 6. So my answer checks out. So don't forget, if you have a whole number minus a mixed number, all you have to do is put in a 0 over whatever the denominator is. And then you can just regroup like I've already shown you. So there you go. That's subtraction with mixed numbers when you have to regroup. Good luck!